Hello and welcome to this model. My name is Stanley Sam and I'm a researcher here at EARWAG with Dr. Christoph Luthi. This is what we would cover in this model. We will explain the difference between greywater and blackwater, present two case studies from Mozambique and Indonesia, and examine the impact of water supply on sanitation systems and on greywater disposal. Now let's first define blackwater and greywater. Blackwater is wastewater from a latrine or a toilet. It is a mixture of fecal matter, urine, anal cleansing materials, menstrual hygiene materials, and flush water. The water content depends on the amount of water which is used for flushing and the containment system. Greywater is wastewater from bathing, laundry, cooking, and cleaning. It may be high in fat and organics and can contain small amounts of fecal matter from bathing children and washing nappies or diapers. Now, typically, wastewater is a mixture of both blackwater and greywater. This graphic shows typical blackwater and greywater scenarios according to the housing density and the type of water supply. If housing density is low and the water is supplied by a public tap, the typical scenario will be a dry pit latrine, the surface disposal of greywater. This usually presents few problems as there is plenty of space for greywater to soak into the ground. Now, water consumption increases and so greywater generation also increases. This may start to form puddles in the yard if there are no specific means of disposal. Many users also choose to upgrade their pits to a poor flush toilet, which may cause the blackwater disposal problems in areas with impermeable soils. This is therefore a more problematic scenario, which is shown in yellow to show moderate risk. Now, for low-density housing with full in-house plumbing, it's typical of high-income areas and adequately designed and constructed septic tanks for blackwater with adequate soakaways for both blackwater effluents and the greywater are usually in place. However, if the housing density is high, there may not be enough space to allow the greywater to soak into the ground, even where consumption is low, as it is associated with public taps. A similar situation will often prevail in houses with yard taps, and both of these situations present moderate risk arising from pools of greywater that can encourage insect breeding, helminths, and unpleasant living conditions. Where there is high-density housing and in-house plumbing, users are likely to prefer flush toilets. But there is usually insufficient space for infiltration of septic tank effluent, and the typical scenario is of greywater and highly polluted blackwater being discharged into the surface drainage system or nearby waterways, which presents a major health hazard. Here are some examples of the different scenarios. Now, we'll go on to look at how water supply can affect sanitation choices. Now, the level of domestic water supply would have a direct influence on the user choice of technology for excreta and greywater disposal. For example, a household that has only access to a public tap for domestic water supply would usually have a dry pit latrine. This has implications for fecal sludge management, as the sludge may be very difficult to pump out, and the pit is likely to contain some solid waste. Where there is a yard tap, users often prefer a poor flush toilet with a water seal. This does not only make the sludge more fluid and easy to pump, but then the water seal also helps to exclude solid waste from the pit. Now, where there is full in-house plumbing, or at least a tap in the bathroom or the toilet, the users often prefer a more aspirational flush toilet which is connected to a septic tank. In this case, the sludge will be even easier to pump out. However, there might also be overflowing blackwater effluent if the soakaway is inadequate. If there is a sewage system, there are many reasons why the household may not be connected to it, and this creates problems which arises from on-site facilities and decrease the cost efficiency of the sewage system. This graph is based on a citywide survey of Maputo, Mozambique, and it shows how improved sanitation is strongly correlated with having piped water on the premises. This may be partly due to household wealth, but given that there are large parts of the city where on-plot water supply is not available, it also suggests that where it is available, the household would rather invest in improved toilets with a water seal. This is based on another survey of an unplanned inner city area in Maputo. In 2011, only about a third of the household had on-plot water supply, and services was very poor. Only about 30% of the household had a water-sealed toilet. Now, a second survey 2 years later, after a major improvement in water supply had resulted in increase to 80% of on-plot water supply, shows almost 2/3 of households with water-sealed toilets. In both 2011 and 2013, just over 80% of households with an on-plot water supply had water-sealed toilets. This again suggests that households were keen to invest in water-sealed toilets once there was easily available and reliable water supply. A few years later, mechanical emptying services capable of accessing the narrow lanes of this same neighborhood were introduced. The water-sealed toilets are generally connected to a septic tank or offset pits. They have high water content due to the flash water and little solid waste due to the water seal, which is part of this system. Thus, mechanical pumping was mostly used for emptying. A far lower proportion of pit latrines was emptied mechanically. This may have been partly due to lower household wealth relative to the septic tank users, but was also definitely due to physical difficulty of pumping the dry sludge out of the pit with a higher solid waste content. This second example from Indonesia shows the effect of on-plot water supply on community sanitation services serving low-income neighborhoods. The development of a new piped water supply reduced the community sanitation centers to about a third. Now, where households had the space, they often chose to develop their own private toilet and bathing facilities. However, the systems households built were often low-quality wet pits. So, in some places, a simple sewer system was developed to transport the household blackwater and then treat it in an anaerobic baffled reactor, which was part of the community sanitation center. Now, water supply on-plot triggers the investment by household owners in aspirational water-sealed toilets. It can also make the pits easier to empty because the water seal reduces the solid waste and the water increases the sludge fluidity. However, the piped water supply also increases the volume of wastewater, and therefore higher amounts of black water and grey water are needed to be managed. These examples show that it is essential for authorities and utilities responsible for sanitation and water supply to work together. Any improvement in the water supply must be accompanied by measures to manage the changing needs for sanitation technology and the increased amounts of grey water and black water that result. Now let's look at how water supply affects grey water management. This table shows how grey water is affected by water supply. As the level of domestic water supply increases, wastewater generation also increases. The higher volume of grey water needs to be well managed. Otherwise, many issues will arise from unmanaged grey water, such as the amount of standing water, insect breeding, damage to unpaved roads, unpleasant odors, and high BOD and COD concentrations in the built environment. These photos show some of the consequences of unmanaged grey water in non-sewered urban areas. Now, some recommendations for disposal of grey water in non-sewered areas. 1. Always keep greywater separated from fecally contaminated blackwater. 2, you can reuse it for watering of trees, gardening, and urban agriculture. And then 3, it can be discharged into a household grease trap and then to a soak-away soak pit or trench. It can even be discharged to a planted bed or horizontal flow filter, or it can be treated by simple anaerobic treatment and then discharged to a covered drain. Now, these diagrams show 2 options. Both start with greywater, which is flowing into grease trap. This captures the grease, grit, and other solids which would otherwise clog up the soak-away and cause it to fail. As shown in the diagram, grease traps have a removable lid which can be opened to enable cleaning out of the trapped solids. On the left, the greywater is disposed in a simple soak-away after the grease trap. This is suitable for relatively small quantities of greywater. On the right, an infiltration trench is used, which can be designed based on its length and sidewall areas to take larger quantities of greywater. In most situations, greywater should not be added to septic tanks, and this is because it increases the volume of fecally contaminated blackwater. It also increases the likelihood of overflowing blackwater and consequent widespread pollution. And also, it increases vastly the soak-away area that is needed. In low-density situations, greywater can be discharged to the garden or trees, to the ground, or to an underground soak-away system. Using a small grease and grit trap will extend the life of the soak-away and help to reduce clogging and blockages. In high-density situations, household soak-aways can be used for small flows of greywater where limited quantities of water are collected from public tap. Where greater quantities of greywater are generated, it will need to be discharged to a sewage system or to a drainage system after pre-treatment in these grease traps. To sum up, water supply projects which increase yard or house connections need to plan for increased greywater disposal. In non-sewered areas, household greywater disposal systems are usually required. They can be simple, but should be tailored to the housing density, local practices, soil properties, etc. Surface drainage systems may need to be improved and expanded. Improvements in water supply often significantly change the type of sanitation systems chosen by the household. It also increases the volume of both the blackwater and the greywater needing safe disposal. It is therefore necessary to coordinate sanitation improvements with water authorities. It is also important to predict and plan ahead for changes in household sanitation when water supply improves. And in non-sewered areas, it is important to promote and make available options for household greywater disposal. It is also very necessary to build more effective soak-aways for septic tanks and upgrade surface drainage systems. Thank you for your interest in this model.